Welcome back, guys. In today's video, I'm going to be covering the concept of dimensional analysis. Now, dimensional analysis is a really important tool that you need to use in general chemistry, especially when problems have multiple steps. Now, in this video, I'm going to be showing how to use dimensional analysis when it comes to a unit conversion problem. Whenever you're converting between units, you want to set up a dimensional analysis problem so you can see your starting point and have a clear roadmap of where you need to get to, right? So let's jump right into it. So the first thing I think about in a unit conversion problem, especially something that has multiple steps, I want to know what my base units are. If I know my base unit, I can then use my prefixes for the units that I know that are out there to get to my final unit. And I'll cover that in just a second. So my base units in the metric system for length, mass, and volume, which are the three common things we're going to measure, are meters, grams, and liters, respectively, right? So if we're talking about length, we're going to be dealing with meters. Mass, grams, and volume, liters, right? These are the base units, right? So I like to think of this as my reference unit, right? If I can get to one of these units, I can then use what I know about the other units to get to those respective units, right? So I listed some of the common units that we're going to see in general chemistry. There are more. This is not a complete list, but these are some of the common units that we'll see. So if we see milli, so we know like milligrams, right? Millimeters, we are going to have a power of 10 to the negative third. One common unit that you're going to see in general chemistry is micro, and it's this, fancy m. It's not the same as this lowercase m. It has this fancy little tail, but micro is going to be 10 to the negative sixth, and kilo, which is this k right here, is going to be 10 to the positive 3. So these are some of the common units that you should know and the powers that you're going to raise to in order to get to that unit, right? So again, not a complete list, but some common ones that we can use, especially to solve some of these practice problems. So how do we use dimensional analysis to do some of these unit conversion problems? Like in all my videos, we're going to do some practice problems to make sure that we have this concept down. So if we have to convert something like 15 grams to kilograms, how would we do that? Well, I would definitely advise against trying to just solve it in the calculator right away. I would try to set up a dimensional analysis problem and go from there. So I have my 15 grams, right? And I like to check to see if I'm in my base unit. So for measuring mass, we're in grams. So cool, we're in our base unit. We can then use some of the units that we know, some of these common ones down here that we should have memorized to get to our final unit, which is kilograms, right? So we have 15 grams. I like to set it up like this, right? So we know that anything across is going to be multiplication. Anything below this 15 down here will be division. So the first thing I like to do in a problem like this is make sure my units will cancel out and get me the unit that I want as my final answer. So if I have grams up here, I need to make sure that grams are down the bottom so I can cancel those out and get the unit that I want, which is kilograms. Okay? So how am I going to do this from here? Well, we know for kilo, right, that's what we're trying to get to, it's 10 to the third, right? So what that means is that for every 1 kilogram, that is 10 to the third grams. Now 10 to the third is the same as 1,000. So 15 divided by 1,000 will give us our final answer in kilograms, right? If we took 15 and divided by 1,000, we can move the decimal point 3 times, and that would be 0.015 kilograms. Okay, so let's tackle our next problem using the same method. So if we have to convert 10 liters, right, to microliters, how are we going to do that? So we have our original 10 liters, and I want to make sure I'm in my base unit, right? Okay, I have liters as my base unit, so now I can use one of these that I know to get to my final answer, right? So I have 10 liters. I want to make sure that I cancel out liters, and I want to get to microliters. Again, this is the symbol for micro. Okay, so micro is 10 to the negative sixth. So I know that 1 microliter is 10 to the negative 6 liters. So I have my final answer. I would do 10 divided by 10 to the negative 6. That's the same as 1 times 10 to the negative 6, right? And I would get my final answer in microliters. Okay? Now, in this last one, we're trying to convert 25 millimeters to kilometers, right? So I have my 25 millimeters. Now, I'm not in my base unit to start, right? If I'm going to be in length, I want to be in meters, right? However, I'm in millimeters. So if I have to go from something that's not a base unit and finish in something that's also not a base unit, what I really recommend is taking the intermediate step of getting to your base unit and then go from there. So I want to go from millimeters to meters to get to my base unit. Once I'm there, I can then use kilo, right, and get to kilometers. So I want to get rid of millimeters, so I know that millimeters needs to be on the bottom and meters needs to be on top, okay? So I know that millimeters is 10 to the negative third, right? So I know that for every 1 millimeter, it is 10 to the negative third meters, okay? And I now need to get to kilometers, right? So meters down here, kilometers up here. My millimeters will cancel out, my meters will cancel out, I'll be left in kilometers. Now, again, now we're in our base unit, we can see that kilometers is 10 to the third, right? 1 kilometer is 10 to the third meters. So if we're going to solve this, what we would do is we'd take 25, we'd multiply it by 10 to the negative third, right? And then we would divide by 10 to the positive third, and that would give us our final answer in kilometers. So make sure that you can use dimensional analysis, set up a problem like this, and be careful when you're doing a unit conversion type problem, because it's very easy to make a mistake unless you have a clear roadmap drawn out with dimensional analysis. So thank you for watching, and make sure to check out more of my videos on the channel.